So let us continue talking about matrices. So you're probably sick and tired of matrices by now. Welcome to well, this is what I used to do when I went to high school back in the day when I used to ride the Stegosaurus to school. We used to do matrices at high school. So what are matrices? We've been doing a lot with matrices. So basically, if you have a matrix, often you'll have a data set. So in this row, each row will have a set of relationships. So 3, 2, 4, 6, 7, 1. So each row here, this might be for a plumbing system, for example. So we've got a reservoir. We'll come back to this in a second. So this might be a valve. So that might be valve 1. This might be for pipe length 1, valve 2. And it gives us the relationship here of all of the data. So each row shows us the relationships down one length of pipe. So this might be row 1. The data here would be row 2. The data here would be row 3. And we're putting all of that data into one place. And this allows us to actually look at many things simultaneously, whether this be wheels, the motion of wheels on a car. And so if I've got a car, so those are springs, believe it or not. These wheels can move in various dimensions. So each one of these would be a variable. So we'd have one set of variables for each wheel, and we'd end up with a huge number of equations, 29 if I remember rightly. So you end up with a very big matrix. But anyway, let's get clear lines. So matrices, the information on each row basically is a data set which has got relationships to each other. It can be more than that. So let's go. I mean, we also store information in matrices. So say I'm going out and I'm doing a rocket engine burn. So here's my rocket engine. Here's the nozzle. I shoot flame out the rear end. I put this on a DAC. So off here, I'm measuring, this could be the force. And here's going to be a pressure transducer. And I might also have a thermistor in there, so a thermometer. So I'd end up with a matrix. I'd end up with a series of results. So time, so for each period of time, I'd get a force, 20 newtons, 25 newtons, 30 newtons. I'd end up with a pressure, 10, 12.5, 15. I'd end up with a temperature, 2300, 2300, 2350. And what I can do is I can store those in something like MATLAB or something as one big matrix. So I can actually store all of the results, time, and what's happening in a matrix, and that allows me to process them. So if there's some other information I need, which I can then superimpose on top of it, then I can add it, I can subtract it, I can do all sorts of shenanigans with it. So often with matrices, we actually store data in them, relationships between data. And this allows us to also store field data. Now, a field, besides a place to put sheep when you're not using them for growing wool or something, it's basically a region of space where you have forces going on. So one that we cover in 201, field data, we might have an array, matrix, and this might represent, say, a harbour. So like Raglan Harbour, so we've got a harbour here, and we want to know what the current's like at any point, what direction the water is flowing in. So we can store this as 2 meters, 2 meters, 3 meters, and now it's land. And we can store all of this data here, this field data, into a table, into an array, into a matrix. So It's one of the most common things we actually use. So if you're doing something like field processing, drawings. So one that we have, I don't know if we're still doing it. I think we do. We've still got range distancing. We have some lovely people down in C Block who basically is a camera for 3D imaging. And basically what they do is they break a region up into pixels, and then each pixel is going to be the distance from the camera. So 10, 10, 10, 9, 9, 8, 10, and so on. So basically you have your camera here. You have your target here, which they usually have a dwarf called Stumpy. It's sort of one of those clay gnomes that you get from down the garden centre. And then and basically what this array or this matrix does here is it takes an image, measures the distance from the camera to the front surface. And then if you want to, you can do really cool things with this image. You can rotate the image, or you can twist the image around so you can line them up. So if I were to take two photos, say, so here's Stumpy, and if I was to take a camera shot here and a camera shot here, I'd end up with one array. I'd end up with an array from here, from this angle. I'd end up with an array from this angle. So if I want to reconstruct the whole three-dimensional image, so I'll end up with I'll end up with matrix 1, I'll end up with matrix 2. If I want to reconstruct the whole image, I'll then go A plus B. So really cool stuff you can do with matrices. So yeah, a lot of CGI nowadays used in computers, computer games, or in films, or if you have to go down and see whatever the latest film is. CGI often has vast arrays of matrices. So hopefully by now, we're giving you some basic skills. So if we have a pair of matrices, A, B, C, D, E, F, G, H, matrices we can also apply mathematics to, just like vectors and things like this. Because remember, vectors are a form of matrix, can be thought of as a form of matrix, a one-dimensional matrix. So we can do basic math, so we can add, we can subtract. Hopefully this is nothing. We can scale them up, so if we want to make everything bigger, we just multiply everything by 2. We can multiply. So hopefully we can multiply vectors together now. Just remember, multiplying C by D is not the same as multiplying D by C, which is, yeah. We can also do squares and powers. And question is, can you divide? Is it possible to do division? I'll give you a clue. The answer is yes. But hopefully we should do that. If we haven't done that already, we should be doing that shortly, how to divide matrices. But these are very, very powerful tools for an engineer. We spend a lot of time examining matrices and putting data into matrices and processing matrices, whether it doesn't matter which field you're in. And what we actually end up using is we end up using a program called MATLAB, because MATLAB allows us to, it's very rare that we actually can do a matrix after a certain point. Well, can't do anything bigger than about 2 by 2, or even or 3 by 3, you can do those by hand easy enough. But when you start getting into the big stuff, like 20 by 20s, it's easier just to use a computer program. But we want you to know what that computer program is doing, because remember, you're in charge of the computer program. The computer program is your servant. You are not the computer's servant. So basically, I'll just leave you with a quick question. You can have one-dimensional matrices. Yeah, so A, B, C, D. You can have two-dimensional matrices. A, B, C, D. Question is, can you have three-dimensional matrices? So is that possible? I'll leave that with you guys to figure out. I won't give you a clue. I'll see if I might put a quick poll up and see who thinks can have three and who can't. But anyway, you've got problems to do. Good luck on the quiz. Catch you next week.